What if I told you there's a speed limit for the entire universe? And not just any speed limit, one that nothing can ever break. Not a spaceship, not a thought, not even time itself. This speed limit is the speed of light, 299,792,458 meters per second. Fast, but still finite. So, why? Why can't anything go faster than light? What's stopping it? What happens if you try? In this video, we'll explain exactly why light is the ultimate speed cap, and why breaking it would break the universe itself. Let's start with the basics. Light travels at 186,000 miles per second. That's fast enough to circle the Earth 7.5 times in just 1 second. But here's the strange part. No matter how fast you are moving, light always travels at the same speed. Even if you're flying toward it at half the speed of light, it doesn't get any closer, any faster. It just stays the same. This bizarre truth was discovered by Albert Einstein, and it led him to create the theory of relativity, one of the most mind-bending ideas in physics. Einstein realized something strange. If light's speed doesn't change, then something else must. That something is time and space themselves. Time slows down for things that move fast. Space compresses in the direction of motion. These aren't science fiction effects. They've been measured with satellites, atomic clocks, and GPS systems. The faster you move, the slower your time ticks. It's called time dilation. So, if you could somehow travel near the speed of light, time would slow for you. But for everyone else, it would keep moving forward. You'd feel like minutes had passed, while years passed for others. Here's where it gets wild. As you accelerate toward the speed of light, your mass increases. Yes, your object literally becomes heavier. This means it takes more and more energy to keep accelerating. And as you get closer to light speed, that energy requirement becomes infinite. To move even a grain of sand at the speed of light would require infinite energy. And infinite energy doesn't exist. That's why nothing with mass can reach or exceed light speed. It's like trying to run through quicksand. The faster you try to go, the more resistance you face. Light is special because it has no rest mass. It's pure energy. So it doesn't need infinite energy to move at light speed. It just naturally does. Let's imagine, just for fun, that something could break the speed of light. What would happen? First, causality would break down. Cause and effect would no longer make sense. You could receive a message before it was sent. You could arrive at a place before you left. This isn't just confusing, it's impossible, because time and space are woven together into space-time, and light speed is the thread that holds them in order. Break that limit, and everything unravels. You might have heard of tachyons. Those are hypothetical particles that always move faster than light. Or warp drives, like in science fiction, that bend space itself to move faster than light. Are these real? Maybe, someday. Tachyons haven't been observed, and honestly, they might not even exist. Warp drives are mathematically possible, but they require exotic matter we've never seen. As of today, they're still totally theoretical. And even if they did exist, they wouldn't move through space faster than light. They'd just bend space to arrive sooner. It's a clever trick, but it's not actually breaking the limit. The speed of light isn't just a number, it's baked right into the very equations of physics. It controls how gravity moves, how energy behaves, how time flows. Even Einstein's most famous equation, E equals mc squared, is built on the speed of light. That c squared shows how mass and energy are deeply linked, and honestly, just how powerful light speed really is. Without this cosmic speed limit, the rules of physics would fall apart. Nothing would be predictable. No computers, no satellites, no you. Light speed is, well, the glue that holds it all together. Still not convinced? Here's how light speed affects your everyday life. GPS satellites have to adjust for time dilation because they move fast and high in Earth's gravity. Particle accelerators like CERN hit 99.999% the speed of light. But never 100%, because the energy required just becomes impossible. Neutrinos, some of the fastest known particles, still fall short of light speed. And despite decades of effort, not one experiment has ever broken that limit. Nature just won't allow it. So why can't anything go faster than light? Because light speed isn't just a speed, it's a boundary, a law of the universe. A built-in safeguard that keeps time flowing, space ordered, and reality from collapsing. It's not a flaw, it's elegance. A silent reminder that even the universe, vast and wild as it is, still follows rules. And within those rules lies all the mystery and beauty we've come to explore. So maybe the real question isn't, why can't we go faster than light? Maybe it's, why does the universe need that limit in the first place?